Okay, lesson 15, part B. We've done part A, page 1. Now we're going to do page 2. So the top of page 2, we have the opportunity to write the general equation for exponential growth again. We've done this several times now on several different note sheets, so we're getting lots of practice. So pause the video and do this on your own. See if you know it. You'll need to know it for the test. So y equals a times b to the x. A is the initial value, which is also the y-intercept, and b is the growth rate. When b is greater than 1, this is exponential growth. When b is between 0 and 1, this is exponential decay. So let's have a situation here. We have a loan of $500, and it has an interest rate of 15%, calculated at the end of each year. So let's figure out what our payments are. So we don't have the year 0 here. We can draw it in if we want. When you first get the loan, you just owe $500. But after a year, you are going to owe $500 plus 15% of $500. Now, another way to write that, you'll get the same answer as if you write 500 times 1 plus the 15% here. So basically what that's doing is saying the 1, 500 times the 1 is going to give us, you can do distributive property. That's 500 times 1 is 500. 500 times 0.15 is 0.15 times 500. So it gives us the same thing that we were doing on the last page, but it's a more compact way to write it. Okay, so let's try it again. Now we have after 2 years. After 2 years, we have to do this twice, right? We have to take this new amount, find 15% of the new amount that you owe. And so what the equivalent of that is actually multiplying it times 1.15 squared. So you're multiplying it twice because it's now 2 years versus of interest compounded on itself. After 3 years, it's the equivalent of multiplying 500 times 1 plus 0.15 3 times, or 1.15 to the third. Alternatively, we could leave it like this. We could just call it 1 plus 0.15 to the third. It would be okay to write it either way. So let's practice some of this. So this way of writing exponential growth equations, or exponential decay, where we're talking about percentages. Notice here, the amount that we owed was growing. So you'll see all these plus signs here, 1 plus. We're going to see how that looks different for subtracting. Okay, so we have $100, a bank account with $100, and we're going to put it through a bunch of different scenarios and see what the equation would be. This first one is done for us. The scenario is that the amount of money in your bank account doubles every year. This, of course, would be growth. And here would be the equation, right? We're working with our general equation, y equals a times b to the x. A is the initial amount in the account, $100. B is the growth factor, how much you're growing by, and then we have the x here. So now let's do a different situation. The amount you have in your bank account increases by 5% every year. This would also be growth. And now we can write this equation, same initial amount, but our growth factor is it increases by 5%. And how we could write that is 1 plus that 5%, 0.15 to the x. It could alternatively be written in kind of shorter form as y equals 100 times 1. Well, I'm really running out of space there. Let me write that somewhere else. y equals 100 times 1.05 to the x. Either way of writing that is acceptable. Okay, now we have to work backwards. We are given an equation, and we have to decide, is it growth or decay? Well, remember, we go up here, if our growth factor is less than 1, this situation, it's actually decay. The amount's going to go down. And 0.97 is less than 1. So it's exponential decay. And we have to think, well, if it's exponential decay, it's going to be decreasing by some amount each year. How much is it decreasing by? Well, it's each year it's 0.97 or 97% of what it was the year before. So that means it must be decreasing by 3% every year. Because 3% plus 97% is 100%, the whole thing. What about if it triples every year? That would be growth. And our equation would be, sorry, our equation would be y, get a little clearer there, y equals, same initial value, 100. Now it's tripling, so the growth factor is 3 this time to the x. Retains 63% each year. That means it keeps 63% of its value. Well, to stay the same, it would have to retain 100% of its value every year. That would be just staying the same as 100%. So this is less than 100%. So that's going to be decay. And now we have to think here. We could set this up in a couple ways. We could say the initial value, and then we could say it's decreasing, it's retaining 63% of its value. Like so. Okay, what about this? Here we have 100 initial value, and then the growth rate is 1 minus 0.03. And if we look up here, when something increased by 5% a year, we added it to the 1. It was 1 plus 0.05. Now we're subtracting it. So if we're subtracting it from 1, that means we're losing money, decaying. I guess we're spending some of our bank account down. And how much are we losing each year? Well, we are losing 3% a year. Now let's take a look here. This is an interesting situation. We had another time when we lost 3% a year. Both of these lose, or you could say decrease, it's the same thing. So are these two equations for these ones? Are these the same thing? Well, let's take a look. Inside this parentheses, we could simplify it. We could rewrite it as y equals 100, and then we could just do the 1 minus 0.3. That is 0.97 to the x. So this is actually the same situation and the same equation. Last one halves every year, so it gets decreased by half. That would be decay. Same initial value, but now the growth rate is in half every year, so it's 1/2 of, it's going to be a growth rate of 1/2. It's less than 1, so that will be decaying. Okay, last thing. We have a situation and we need to write an equation. Let's see if we can do that. A person takes 800 milligrams of an antiviral medicine. The amount of medicine left in the body is reduced by 25% every hour. Y is going to represent amount of medicine, and X is going to represent the time in hours. Again, we're going to use our same basic equation. Y equals A times B to the X. So A is our initial amount, the initial amount of caffeine or medicine in the body. Growth rate, it's reduced by 25%. So going down 25%. So we're going to say 1 minus 0.25. to the x. We could leave it like that, or we could simplify. We could say y equals 800 times 0.75 to the x. So the same thing as being reduced by 25% every year would be equivalent to say, or not every year, every hour. Each hour, the amount of medicine in the body is 75% of what it was the hour before. Okay. Now we have another situation, and a laptop is $800 and it loses 75% of its value. Same thing, we're going to write an equation in our general form. So we have $800, initial value, 800. Oh, similar here, but that's in milligrams. This is in dollars. It's losing 75% of its value. So now we're going to say here it lost 25, there was 25% less each hour. Here it's 75% less each year. So we're going to say y equals 800 times 1 minus 0.75 to the x. So that is y equals 800. We could leave it like that. That would be fine. Or we could simplify it. 1 minus 0.75 is 0.25 to the x. And a way to think about this is each year it's only worth 25% of what it was the year before because it lost 75% of its value. All right, that's it.